Hey everyone, we're going to look at an example of finding instantaneous rate of change while staying in terms of x. We already have an average rate of change formula from Algebra 1 using 2 points. I've adjusted this formula so that it reflects function notation. And this is the formula that we're going to use for instantaneous rate of change. The 2 points that we're going to use are x and the y, or f of x, and then some other point that is some unknown distance away on the x-axis from our first point. If we adjust the slope formula using those 2 points, this is what we get. F of x plus h represents the f of b, the second y value. F of x represents f of a, the first y value. X plus h is b, the second x value. And x represents our a, the first x value. So we have to use 2 points in order to use our average slope formula. However, in order for us to find the instantaneous rate of change, meaning the slope at one given point, we need to essentially make this point, this x and this y, the same as this x and this y, which means that this h value needs to go to 0. Or in other words, we are going to find the limit as h approaches 0 for this average rate of change formula of these 2 arbitrary points. So let's jump right in. We're going to find the instantaneous rate of change for the function 2x squared plus 1 at the point x equals -3. Remember, we want to find the limit as the distance between this x value and this x value goes to 0, so in other words, h goes to 0, of this slope formula for our 2 arbitrary points. So we will do the limit as h approaches 0 of f of x plus h minus f of x all over x plus h minus x. Once I've plugged into my instantaneous rate of change formula with the limit, all I need to do is use algebra to simplify so that the h in the denominator will cancel out. So let's take a look at the top. I notice that I have a binomial squared, so I'm going to use FOIL to expand that. And don't forget this 2 out here in parentheses, that's a very common mistake to drop that coefficient out there. So I've expanded my x plus h quantity squared, and I've also brought down the plus 1. It is also a very common mistake to drop this as well. There's nothing that I can do to simplify the 2x squared plus 1, so I just bring it down. In the denominator, I have x and then minus this x, which will cancel out, giving me just h in the denominator. Now here's the step where some people try to substitute my limit value into the equation. And we can see right off the bat that if I do that, I get a 0 in the denominator. So I need to go a little bit further to try to simplify the numerator so that this h in the denominator will go away. Looking at my numerator further, I can see that I can distribute the 2 into the expanded binomial. Keep in mind that this plus 1 is on the outside of the parentheses, so it doesn't get multiplied by the 2. I can also see that there's a negative in front of my f of a, or the 2x squared plus 1. So this will always distribute into all of your f of a value, giving us minus 2x squared minus 1. At this point, it's all cancellation. We have 2x squared and minus 2x squared. Those 2 will cancel out. We also have positive 1 and negative 1. Those 2 will also cancel out. And if you notice, we are now left with only terms that have an h in it. And now we have 3 terms that all have h in them, so the h's will divide in nicely. And now the denominator will go to 1, leaving this term as 4x and this term as 2h. Now that my denominator no longer has an h in it, I can use my limit value and substitute in to get my instantaneous rate of change. So I substitute 0 in for h, and that simplifies to 4x. This expression represents the slope or instantaneous rate of change for any point on our original function, 2x squared plus 1. If I go back to the original problem, I'm finding the instantaneous rate of change at x equals -3. So using the formula that I got, I can substitute my x equals -3 and simplify to get -12, which is the slope for 2x squared plus 1 at x equals -3. Since we use the average slope formula to find this instantaneous rate of change, we now know that instantaneous rate of change is the slope of a given function at a point. Not the average over an interval, but the slope at a point.